Hello and welcome back to our last live 37 beat.
Can you believe it?
Oh my gosh, where's the time gone?
It's awesome.
Well, I'm Ann Wellington.
And I'm Slade Bradbury.
And this afternoon we are actually over in Broadmoor Hall. We are here at the National Oceanic and Atmospheric Administration booth.
Nice job on that.
I've been practicing that all day.
Well done.
And I know you personally love NOAA.
I have been a big fan of NOAA for quite some time. I relied on a lot of their data that the satellites produce for weather reasons, of course, because I'm a climber, I'm a surfer. I relied on NOAA all the time for surf updates and when the swells were coming in. But more importantly for the weather, I'm a weather geek. But they offer so much other data that tells the people, like the just regular Joe Schmoes out there, about how the Earth is living and breathing. And I just can't wait to hear what we have to hear today for our 37 beat viewers.
I was going to say, I think today we are talking with Rafa.
Yeah.
And he is actually NOAA's lead of the Environmental Visualization Lab.
Sweet.
And what's really cool is I think he actually has a presentation to show us.
Awesome.
So
I can't wait to see this.
Yeah, me neither.
Hi folks, I'm going to talk a little bit about what we do at NOAA, from the surface of the sun to the depths of the ocean. We're going to start a little tour here. We're looking at the sun. We have several satellites that are continuously monitoring the sun because we're looking at that output that's coming towards our Earth. The sun brings all the energy that we have, and that energy goes into the atmosphere. This is also something that we're observing at NOAA. All the atmosphere, 24 hours a day, 365 days a year. We're operational, always monitoring it and making sure that everything is understood in these Earth systems. Here are the oceans. This is also something that we're continuously monitoring. We're looking at sea surface temperatures here around the world, all the way into the depths of the ocean. We also look at that bathymetry and topography across all the world. This is the domain of NOAA, from the surface of the sun to the depths of the ocean. And how do we do this? How do we monitor all this? Well, we can do it with in situ measurements, like releasing balloons into the air to measure that temperatures as it goes up. We have ships, we have buoys around the world, but it would be impractical to cover the whole world in buoys and sensors, right? So what we do is we use satellite technology to do that, to supplement that. We have satellites that are continuously orbiting the Earth, scanning the Earth for that data, and creating a record so that we can understand how the Earth looks right now, how it's looked in the past, and how it's going to look in the future. And here is our constellation. Nations of satellites are orbiting around the Earth continuously, and what we're going to start doing is we're going to start turning off the satellites that are not Earth observation satellites, little by little. Here we're seeing GPS, the space stations. Right now we're turning off and we're just leaving our NOAA satellites. So we have those polar orbiting satellites that are the ones whizzing around the world right there. And over there, those GO satellites, the ones that are fixed in the space, those are our geostationary satellites right there. And those, we just launched a GOES-T satellite just 1 month ago. It's already in its geostationary orbit. We call it GOES-18 now, and we expect it to be GOES-West sometime operationally in early next year. This is a little bit of a visualization of before and after, if you may. So we've had satellite observations for over 60 years now. NOAA has been around for 50 of those years, and we've been building that archive with all this satellite observation. And of course, as years go by, you can see there from 1967 to 2017. Just, this may look rudimentary, but it gives you an idea as to how that technology has evolved from looking at the Earth and trying to capture that data to Earth in high definition, which is what we can see now thanks to our NOAA satellites. And what we have here is why we do this all for. Here you can see in blue, it's all the routes over the ocean. In red, you can see all the airline routes, and in yellow, it's all the on-land routes, roads and things like that. This is what we do everything for. We're making sure we monitor weather and climate to make sure that all those flights and all those boats and all those shipments get to place safely and properly. Basically, protecting life, protecting property, and economic vitality, from the surface of the sun to the depths of the ocean.
Oh, wow. Oh my gosh, that was a wonderful presentation.
Absolutely.
What did you think, Ann?
I didn't realize you guys did so much, but that's incredible. Thank you so much.
I love NOAA. You help inform people about how to measure all the phenomenon that happens, from space weather, which all gets produced by the sun. That's why I love your line from the space to the depths of the ocean. That's amazing.
Yes,
God, I'm super
absolutely.
impressed.
Yes.
Thank you so
That was
much.
wonderful. Thanks, folks.
Well, guys, what do you think, Ann?
I mean, for my first symposium, this has just been absolutely mind-blowing. I think we've had some really great conversations.
Totally.
There's some really cool people here, obviously.
Very cool people, very smart people, helping inform
yes.
everybody else.
I'm so thankful and grateful to have been a part of it this year. It's incredible.
Me as well, and
Yes.
I think that's what our mission is to just keep the conversation going, inform everybody else so we're everybody on the
Yes.
same page, and we just, oh gosh, this has been such a treat. Way to go.
Yes, we did it. Woo!
Woohoo!
All right, well, I think that's about all we've got for today. So thank you so much for joining us for our last live 37 Beat.
Yes, thank you so much.